everybody. EX1. Let me take a look at my notes. All right. Let's okay. Let's do this. I'd like you to find the LA and SA of the prism. Find the LA and the SA of the prism. All right, let's do this. I'd like you to make. We just made a hexagonal six-sided prism. We're gonna knock it down a side. I'd like you to make a pentagonal prism. Pentagon is 5, everybody. So here, I'm just gonna write this down. Pentagonal prism. Oh, this is gonna be brutal. It is hard to draw a pentagon, even for Mr. Kosal standards. Not a big fan. All right, here we go. Let's do this. B. Cool. There is your pentagon, 5-sided shape. Pause this video if you are not happy with your pentagon. I'm trying to make it a regular, meaning all the sides, all the angles are the same. I already talked about that. And to be quite honest, this does not look like a regular pentagon. It does not look like all these sides are the same. That's fine, because you got to remember, we are looking at this at 3 dimensions. If you went back up here, that looks pretty perfect. That looks pretty darn good. That doesn't, but if we were looking at it from a top view perspective, then you could kind of see that, yeah, it looks like a regular hexagon. If you look at this from a top view, then it would be, looking like a regular pentagon. Let's give it some height. Let's give it height. Now, here's a good tip, everybody. Whatever this distance is to the bottom height, it needs to be the same from here to here. And this needs to be parallel with this line that I'm about to draw. So if I'm going to take this lateral edge right here and bring it down, it needs to be parallel with this one right here. Don't go off in this direction. Don't be going all wanky like this. And they have to be parallel. They have to be vertical with each other. Okay, so that was this. Maybe just a little bit longer. Okay. Yeah, okay, I'm happy. Connect. You'll be surprised in how good your prisms turn out. Alright. Are you starting to see it 3-dimensionally, everybody? Here we go. Let's go down to about right here. I don't know. Make it straight up and down. How are we looking? I guess I could just measure it. I have a ruler after all, but why do that when you can make things complicated? Also, this line that you're about to draw should look parallel with that line. We've got a whole bunch of parallel lines going on here, folks. Cool. All right, one more. Pretend like we're looking through it. It's made of glass. Okay. Honestly, drawing it is kind of the most difficult part, isn't it? Okay, that looks about right. Notice how these look parallel? These two right here? Not bad. And then if you do this right, the very last edge should look parallel right here. Perfect. We have a regular pentagonal prism. I'm going to give you a couple things. Here, folks. I'm going to tell you that one of these side lengths is 5 centimeters. And I'm going to tell you that the height of this prism, let me say that again, the height of this prism from here to here is 3 centimeters. Sweet. That's it. That's all I'm going to give you. I'm going to give you nothing else. We need to find the lateral area and find the surface area of this prism. Okay. First things first. Might be a good idea to identify, what do we do up here? Might be a good idea to identify the 2 bases the two bases up here were the two hexagons. The two bases here, oh, I really hope you see this, everybody, are the two pentagons, the top one and the bottom one. And then hopefully you can identify the lateral faces. Now up here they were the rectangles going from top base to bottom base, kind of stretching them. These tall blue rectangles. This time, oh, they're not as tall, but I think they're still rectangles. 1, 2, 3. Question, how many rectangles do we have? It's not 6 anymore. You should have 5 lateral faces. There should be 5 rectangles. It's 5 because we're not working with a hexagon anymore. We're working with a pentagon. A pentagon has 5 sides. So there should be 5 rectangles. And the last 2 are right here and right here. I know I'm drawing on this a lot. It's difficult to imagine, but stay with me. Visually, stay with me. Alright, so let's start with the easy one, folks. Let's do lateral area. Lateral area. Well, we just need to find the area of one of these blue rectangles. And then because we got 5 of them, multiply by 5. Cool. Lateral area. Gosh, we should be done with this really easily. Let's take this front rectangle right here. Let me kind of highlight it for you. I know that the length, or you could call it the width, one of the dimensions, is 3, but we don't have this. Darn. Or do we? Well, one of the important parts of this problem that I kind of wrote down here at the last minute was this word right here, regular. And regular means that all the sides of the pentagon are exactly the same. If this is 5 centimeters, that's 5. That's 5. That's 5. Shoot, they're all 5. So if this is 5, well then we can have a 5 by 3 rectangle. 5 by 3 rectangle. So that's going to be 15. Well, it's not 15 because that's 1. And now I need to multiply it by 5 rectangles going around the outside. Remember, lateral area, you're kind of going around the outside of the figure. Okay? And 15 times 5, everybody, the lateral area is 75. Now it's area, so the units of measurement are going to be centimeters squared. Alright. I usually tell my students that lateral area is the easiest of the two to work with. Surface area, let's see, what is surface area? Well, surface area is lateral area, but you're also adding the 2 bases. You're adding the top base and the bottom base. So up here you're going to add the top hexagon, the bottom hexagon. Down here, well, I think we got to add the top pentagon and the bottom pentagon. So let's get this set up here. I was getting ready to write lateral area. Surface area is going to be the lateral area plus 2 bases. I'm talking top base, bottom base. So we already have the lateral area. It's 75. Folks, it's the 5 blue rectangles. Plus 2. I've got that 2 right there because that 2 represents top and bottom. Once you find the area at the top, you multiply it by 2 to get the bottom. That's what that represents. Now we just need to find the area of the yellow pentagon. I really hope you watch my lesson from 11.4, which is finding the areas of regular polygons. Because in 11.4, I introduced to all of you students a very important formula, the area of a regular polygon formula. Looks like this. I'm going to write it sideways because I'm kind of running out of paper and room here, but hopefully write it down somewhere in your paper. The formula to find the area of a regular polygon is 1/2 little a big P. Does anybody remember that? Feel free to just say it out loud. I know nobody can hear you, except your parents in the other room. Yeah, I remember that. Area equals 1/2 little a big P. Little a is the apothem, big P is the perimeter. So, and that's going to find the that's going to find the area of the pentagon. I know we're caught up in this problem where we're trying to find the surface area, which is the 5 lateral area, the 5 rectangles plus 2 bases. But I need to find the area of 1 base. So once you find the area of that pentagon, put it here, multiply it by 2, add the 75, you're done. So folks, we need to find the area of a base. Area of the base, which is a pentagon. So we're going to use this equation here. A equals 1/2 little a big P. So let's go ahead and do that. A equals 1/2 little a. Do we have the apothem? No. Do we have the perimeter? No. Wait, yeah. Yeah. Do we have the perimeter of this figure? If every single one of these are 5, what's 5, 5, 5, 5, and 5 added together? Perimeter is 25. Now we just need that little a. We just need the little a. So let's do this. Let's create the apothem, everybody. I want you to just focus on this figure for me. Remember what the apothem is. I'm going to put the center of the pentagon. And if you remember, if you connect the center with all the vertices, these are called radii. These are not apothems, they're called radii. It's the radius of the circle. Now, the apothem goes from the center. It's the height of this one of these triangles right here, the 5 triangles that you created is the height of one of the triangles. It makes a right angle, cuts these two sides in half, and also cuts this angle in half. Hopefully you can see these two little dots right here. We need to find the apothem. Let's call it x. I know this is a lot of work, but we're almost done. We got to get this, folks. I showed you when we found the area to start by working with these central angles. Now because there's 5 central angles here, let's take 360 divided by 5, and I believe that's 72 degrees. So what I'm trying to show you is this is 72, that's 72, that's 72, they're all 72. And more importantly, this is 72 as well. But the apothem cuts that 72 degrees in half, making, well, what's 72 cut in half? Some of you forgot about this when you did the homework. 72 cut in half is this angle right here, 36 degrees. That's a triangle I want you to work with. That's a triangle I want you to work with. In fact, I'm gonna redraw it. So 36 degrees. I need to find the apothem. And okay, what side do I have? What side do I have? Oh, this side right here. I have that side. Oh, I do. I absolutely do. If that total side is 5, because it's a regular pentagon and every single one of these sides are 5, then this is going to be half of 5. That's the other half of the 5 because these two pieces are exactly the same. Half of 5 is 2.5. All right. And this is when I need my calculator. And I'm going to signal my wife across the room because I do not have my phone. I have no idea where my phone is. Maybe upstairs, possibly charging. Folks, I'm going to see if you can find X right here. You Sokotoa as I go find my phone.
2,000 years later.
A math teacher with no calculator. All right. Did you guys find this? Sokotoa, everybody? Okay. Sokotoa. Is it sine, is it cosine, or is it tangent? Everybody, it's tangent because this is your opposite and that's your adjacent and there's your hypotenuse. So how about the tangent? 36 degrees equals the opposite, 2.5, over the adjacent x. And hopefully we multiply by x on both sides. So x times the tangent of 36 degrees equals 2.5. Okay. Divide by the tangent of 36 on both sides.